Hello everyone and welcome back. My name is Mr. Kovalt, and in this video we're going to go over Le Chatelier's principle and the effect of volume and pressure. So let's get into this. So again, what is Le Chatelier's principle? Le Chatelier's principle basically says that if you have a system, a chemical system at equilibrium, and that system is disturbed in some way, the system is going to shift in such a way as to minimize that disturbance and relieve that stress, if you will. So in today's video, we're going to go over the stress or disturbance of changing volume and pressure of the system in equilibrium. So here is our reaction for this video. So the reaction is we're taking some nitrogen gas, we're reacting it with hydrogen gas, and we're getting some ammonia from that. And so you'll see that one molecule of nitrogen requires 3 molecules of hydrogen to form 2 molecules of ammonia. So how is changing volume and pressure going to affect this system? And what is the system going to do to minimize or undo that stress or that disturbance? So we have to go back to the ideal gas law here. So the ideal gas law tells us that the pressure times the volume is equal to the number of moles multiplied by the ideal gas law constant multiplied by temperature. And so temperature is in Kelvin, and the amount of gas is in moles, volume is in liters, and pressure is in atmospheres, depending on what R value you're using. So if you're using 0.08206, then that is going to be the units for these other characteristics of the gas. So this is our ideal gas law, and as you can see that the pressure and volume are related to the number of moles, right? So you can see that increasing pressure or increasing volume would be related, inversely related to the, or directly related to the number of moles. But before we get to that, let's remind ourselves that the volume is going to be proportional to the pressure. So if you increase the volume, remember, if you increase the volume of your system, then the pressure of that system is going to decrease. So increasing volume is going to decrease pressure. Uh, in decreasing volume will increase pressure. And so we can see that here in this piston example. So if we remember, so if we decrease the volume here if we push down the piston and we decrease the volume, we're squeezing those particles together. And what's going to happen? Those particles are going to be hitting the sides of the container with more frequency, and so therefore the pressure increases. So decreasing the volume increases the amount of pressure inside. Uh, on the opposite hand, if I lift the piston, so if I lift the piston and I increase the volume, so now I'm giving the particles more space. They have more room to move in. The amount of collisions of the side of the container is going to go down, and therefore pressure is going to decrease. So increasing the volume decreases the pressure of the gas. Okay, so that's a good review of the relationship between pressure and volume of a gas. And so now, how does this relate to Le Chatelier's principle? And how does the effect of volume and pressure cause the system to shift? Well, if we're keeping in mind also that if we are changing the volume or pressure of the system, then the system is going to want to shift in order to decrease or increase that effect or decrease that effect. So, for example, let's say that we're decreasing volume. So volume decreases, we're decreasing the volume. That means that the pressure is going to increase. So we're increasing pressure. Well, what does the system need to do to decrease the pressure? Well, if we go back to PV equals nRT, we notice that one way in which you can also increase or decrease pressure is by increasing the number of particles that are in the container or decreasing the number of particles in the container, right? So if I keep the volume the same here and I just remove some of the particles, then by removing the particles, I've decreased pressure. Or if I add more particles to the system, right, the more particles I add, then more collisions to the side of the container, more pressure. So increasing or decreasing the number of particles will also increase and decrease the pressure. So if you decrease the volume of the container and thereby increase the pressure, the system can undo this increase by decreasing the number of particles. Well, how is the system going to do that? Well, if we look at our equation here, what side has more particles, which side has less? And here you're going to want to look at the coefficients. So here we have 1 molecule of nitrogen, 3 molecules of hydrogen, and on this side we have 2 molecules of ammonia. So on this side we have a total of 3 plus 1. That's a total of 4 molecules altogether. And here we have 2. So which side has more particles? Well, this side does. So if we decrease the volume like we do here, and thereby increase the pressure, the system is going to undo that. It's going to try to decrease that pressure back to what it was before to reach that equilibrium state. And so in doing so, it's going to, hold on a second. In doing so, that darn light. So in doing so, in order to undo the pressure increase, the way it's going to do that is by decreasing the number of particles. And the way it's going to do that is by shifting to the side that has less particles. So since this side has less particles, then the reactants are going to decrease. So we're going to decrease the amount of particles here by taking these particles to make these, because this side has less particles. So if I take 1 nitrogen molecule and 3 hydrogen, I can take those 4 and decrease it into 2 particles of ammonia, and thereby I can decrease the overall number of particles in the reaction vessel, and therefore that's going to decrease the pressure until I can reach that equilibrium state again. And so in this case, for this particular reaction, it would shift towards the products. So it's going to shift right. It's going to shift right towards product. It's going to make more product in order to undo that increase in pressure. Okay. Now, what if instead I increase the volume, right? So if I increase the volume, if volume increases, then that means that pressure is inverse. The pressure is the opposite. So pressure is going to decrease. So what is the system going to do now? Well, the system is going to shift in such a way in order to increase that pressure back up. And so it's going to have to manipulate or affect the number of particles in the reaction vessel in order to do that. So how is it going to increase that pressure back up? Well, it's going to have to increase the number of particles. And since this side has more particles on it than this one, it's going to have to shift towards the reactants to create more particles. And so you're going to take two of these molecules of ammonia and you're going to break them down and back into nitrogen and hydrogen. And so that's going to increase the number of particles and therefore increase pressure back up until you can get that equilibrium again. And so in this case, you would shift towards the left, towards the reactants. Now, this is because if it shifts right or left depends on which side has more or less particles. So different reactions are going to have different numbers of particles on both sides. So the shifting right or shifting left is going to depend on the reaction, and it's going to depend on which side has more, which side has less particles. But I hope this helps explain or clarify how Le Chatelier's principle is used to determine which way the system is going to shift when you change volume or pressure. I hope this is helpful. If you like this video, please smash that like button right here. And also, if you please subscribe to my channel, hit that notification bell right up here, so that way you can be notified by other videos I'm going to be putting out. Put a comment in the comment section right down here. Let me know what you think, and if you have any questions for me to answer. Thanks for joining me. Have a great day.